In this video, we are going to solve some exponential equations that do not involve calculus. Reason is they are all set up for the bases to match. So they're all set up to look like this, where whatever this is with an exponent is going to equal the exact same thing, except it's going to have a different exponent. So if we can get the bases to match, then we can just set the exponents equal to each other and solve. So they're all set up for that to work. So it's not a coincidence that 32 is a bunch of twos. So if you kind of test that out, you have 32 is 2 to the 5th power. So that's just me kind of trial and error. 2 to the 4th, don't know, 2 to the 5th, oops. 2 to the 5th, and there we go. So I'm going to rewrite my 32 as 2 to the 5th because I want it to look the same as the left. Oops. So that's what I'm looking for. I'm looking for these two pieces to match. If they match, now I need the exponents to match as well. Then they'd equal each other. So now I can kind of just focus on the fact that my exponent needs to equal 5. And that's the answer. Now they're going to get a little bit more complicated than that, but that's the basic idea. Is if you did 2 to the 5th, you'd get 32. All right. So something like this, 5 to a power. I guarantee that 125 is made up of a bunch of 5s. I just have to figure out how many. So 5 to the 2nd is 25. 5 to the 3rd is 125. So I can rewrite it. So 5 to some power is going to equal 5 to the 3rd. And then again, the only way that these things match is the bases match and the exponents match. So now I can just focus on the exponents. And there's nothing left to do. That's it. So 27 is a bunch of 3s. So I'm going to test it out. 3 squared I know is 9. So 3 to the 3rd is my 27. So 3 to the x plus 1 on the left side. I can rewrite this as 3 to the 3rd on the right side. And then now if the bases match, the exponents need to match so they equal each other. So the x plus 1 exponent needs to equal 3. And so I subtract 1, and x equals 2. So if I took and plugged a 2 in here, I would have a 2 plus 1, which would make 2 to the 3rd. All right. And then the last one, 64. 64 is a bunch of 4s. I just have to figure out how many. So I know 4 squared is 16. So 4 to the 3rd is 64. So I rewrite that. So the left side is still 2x minus 1. The right side is 4 to the 3rd. And so now again, if the bases match, my exponents need to match. So 2x minus 1 needs to equal 3. I add 1. 2x equals 4 by 2. X equals 2. Okay, so that is how you solve exponentials. This chunk specifically is not meant to use a calculator because the bases can match on both sides. And if the bases match on both sides, then really I'm just focusing on the exponents that equal each other.